All right, so the least squares regression line or best fit line, it minimizes the sum of the squares of residuals the sum of the residuals is always 0. It always passes through the point x bar, y bar. Okay, because this is like the average stuff, so they have to offset for the line to be like a true average of it. And then the slope of the regression line is m equals r times s sub y over s sub x, which is equal to b1. So that's how we would find it if you were, depending on what information you were given. Alright, so there is a positive linear association between the height of adult males in inches and their weight in pounds. Below is a list of the relevant summary statistics. So we have the mean and standard deviation for both, and then the correlation is just in general that it's kind of misleading, but it should be like its own thing. It's not like correlation for height, and it's not like one's missing for weight. So there's a correlation. So as basically you get taller, your weight's going to increase is what that's implying. So we have x and y. So find the slope of the linear regression line, and what does this mean in the context of this problem? So we're using this slope formula up here to plug stuff in. So B1 is equal to R, which is 0.768 times S sub y over S sub x, so 21.05 over 2.18. And then that's going to give you your slope. That's not what I have on my paper, but I could have something wrong.
Oh, I divided. I didn't multiply.
Okay, I was like,
Yeah,
okay.
I divided twice instead of dividing.
Ah. Okay. There we go. So in context, this would say that for each additional inch of height, because that's what's being changed, and we know it's inches because of how it's listed up here, the weight increases by 7.42 pounds. So we want to write our equation for the linear model, and then we're going to use it to find out what a predicted weight for a 75-inch tall male would be. So just as a refresher on the formulas, y hat is equal to b sub 0 plus b sub 1x. Now, to find B0, because we don't know what the initial value is, we've got to use the B sub 0 equals y bar minus B1 x bar. So those are our averages with the B1 that we just found previously. So that's going to be 153.6 minus 7.42 times 71. Yeah.
Why can't I like not type? I just
Negative 373.22.
Negative 373.22. Is that what you said?
Yeah.
Okay. So then what would my equation of my line be?
negative 373.22 plus your B1, which is 7.42 times 75.
Okay, yeah, so in general it would be times height, and that's equal to weight hat. And yes, we would plug it in for $75 for that one.
$183.28.
So then, what?
Oh, are you nervous? You'll do fine.
You got it. What proportion of variability is explained by the regression model with height? So how do I find the variability? Or what value is that?
That's the predicted. The actual.
It has something to do with R.
R2. No, it's R1. I mean, just regular R.
Well, R is correlation.
Oh, yeah, no, you're right. So,
Oh, the original.
When you're saying R2, are you meaning R squared?
yes.
Okay.
That's what I mean, but
Okay. I was like,
Yeah,
I
no.
think that's what she's trying
R
to
squared,
say.
That's what I'm trying to say.
So then we have 0.768 squared which is what?
0.59.
Yep, which is going to be 59%. So then what we can say about that is about 59% of the correlation in the men's heights can be explained by the regression with their weights.